Welcome to BJT. Resources you will need.
Today we will learn a basic IoT example using AdaFruit and ESP8266 NodeMCU. Before we start, we need to get a bit of IoT. As you heard, it's a full form Internet of Things. In the center, you see IoT ecosystem. And everything is connected to this internet thing. Home, car, electric bulb, home lock, solar panel, battery, cell phone, laptop, satellite, etc. So all things are connected to internet. That is the basic definition of IoT, that is Internet of Things. So everything is connected to internet. Now how it can be realized? There are two terminology that we have to understand. One is subscribe and another is publish. So in general we can understand that publish means send and subscribe means receive. Okay. So suppose we are having a temperature sensor equipped with NodeMCU, so it will publish or send its sensor value to the MQTT broker, or better to say server. Here it will work as a AdaFruitIO. Fine. And if we listen something from this server, then we need to have subscribe. Fine. You can also understand this in the same fashion that if you are having a laptop, then the server can publish the value, so for that purpose you have to subscribe it. Fine. And similarly, if smartphone is subscribed to it, so that it can publish some value and you will able to get it. So this is the concept of publish and subscribe. So you need to be very careful when we need to publish and when we need to subscribe. Now let's have a look at the code. Here please pay attention. We will switch meanwhile towards the code, then again into the web browser section, and so and so. So we have already included this library earlier. Now here are two more statements in line number 6 and 7. There is a single library, AdaFruit MQTT master, that you have to download and include it. Fine. Then rest things are same as we discussed earlier. Now in the line number 12, we have mentioned that you have to create an account on AdaFruitIO. So let's go to the AdaFruitIO and try to create an account. AdaFruitIO, get started for free. Last name, email ID I have to change it, username, password will be. Now create account. Now save settings. Insert your password. These are mandatory things, so you have to mention it. So now task 1 is done. Account has been created on AdaFruitIO. Then we have to define AIO server as ioadafruit.com, AIO server port 1833 and 8883 for the secure socket layer encrypted, and AIO username and AIO key. You will get this from the account. Now you have to go to the AdaFruitIO thing. When you visit this page, here it will show you AdaFruitIO key. So you can check it out, username and active key. So you can copy it, and here it is for Arduino, here for Linux shell, here for scripting. Now we have to create a client that can be connected to MQTT server. So here we need to mention the line number 21, that is creating AdaFruit MQTT client. It will receive client address, AIO server port, AIO username and AIO key that we have created in the line number 13 to 16. And then we have talked about subscribe and publish. So here right now we are not working on any sensor, so we are just receiving a value from the server, MQTT server. So we need to subscribe so that we can listen. In this case, MQTT server will publish and we will listen. So we have to subscribe to that. So here we need to create AdaFruit MQTT subscribe variable, that is we have taken here lamp just to symbolize LED, and in the constructor thing we will pass the MQTT. This MQTT is the MQTT client, and then AIO username. Then in the double quotes we have to mention feeds/lamp. That lamp should be same that has been created in the account. So I will let you know from the account here how can you create. Here you can see feed, click view all. Then in the action section you will have an option of create a new feed. So we will go to the create a new feed. This feed is just like a variable. It should be same as we have mentioned in the code. So lamp, then description, LED you may mention, create. So this lamp is inside feed. As you see here, we have successfully created a lamp feed. Now integer lamp pin is equals to 5, that means it is connected to pin number 5, that is D1, and then pin mode is output has been set and down, and default this pin should be off. That means we are working on active low. While it is 0, the LED should be on. Fine. Then we are connecting to the wireless port. Done. In the loop section we are calling two functions, MQTT connect and subscribe receive. We have created with our own. So first MQTT connect. What is MQTT connect? It will try to connect MQTT server each time if it will get disconnected. So it is checking out if it is connected, then return, otherwise connecting to MQTT, and it will retry like this. So this code deals with connected with MQTT server. Now the second one is subscribe receive. Here we create another pointer variable of AdaFruit MQTT subscribe, that is subscription, and MQTT variable that we created earlier at the top, here MQTT client. So this client will give us read subscription 1000. That means it will read the content and that will stored into subscription. It is not the equality symbol, it is just storing this. In line number 78 we are checking out subscription is equals to lamp address. So the lamp has been created as a feed. So whatever has been readed out is equals to lamp. Then the lamp dot last read has been converted into a string. So we are typecasting here, and that will be stored into the value. And we are printing here received message and the string value. Now we have received the value. Now we want some action to be performed. This value has been again stored into the string variable, and it has been trimmed out if there is some extra space. Then we are comparing message is equals to on, then digital write lamp pin comma 0. That means digital pin should be forces 0. So lamp will be on, and message, the same message has been stored with the text value. So it will be displayed that lamp should be on. In the else category, if it is off, then we are printing the off. Now as you have created a feed here, you need to create a controlling components here, and we can find it out in the dashboard section. So till this point in your account you will not have any dashboard, so you have to create a dashboard. So you can say test dashboard name and create. In the test dashboard, when you double click, it will open like this. Now you have to add block from this section, create new block. So by default it is showing a toggle one, so we want this. Now we have to associate this block with some feed. So here we are having only the lamp feed, so we can go ahead, and block title should be lamp, you may give lamp control, and it is having two values. You can also fix some binary values to these blocks, but here we are having text only. So here it is a toggle button having on and off value, and it has been connected to the feed. So till this point task has been done. Now we have to learn the circuit. In the circuit you can see the cathode point should be connected to D1 and anode point via resistor connected to 3 volt directly. Here if you are having higher capability of the LED, you can omit this resistance also. This is a layout diagram in which symbolic representation has been done. Symbolic representation of LED, symbolic representation of resistance. So sometimes you may find such kind of diagram also. So be prepared for everything. Now we will connect the board and upload the code into NodeMCU. Check it out whether it is detected port, not detected. So again we do it. Now detected. Now upload. You can check it out. We have not connected the circuit diagram till this point, and always be careful in this case, and do not use USB power until unless you will not have much load rather than LED. In case of LED we can use the USB power, otherwise we have to go with the adapter power to supply the board. Done uploading. Now again I will remove the USB cable and insert LED at pin number D1. Here I am not using the resistance with this LED because it is capable of handling 3 volts. So I have connected this one directly. Now we will go to the dashboard. We have created that subscribe. Now you can check it out. When I turned it on, it is getting on. If it is not getting on and off, then first we check out the serial monitor. After connecting LED, I have to insert USB again to provide the power. Now I will go to the subscribe dashboard and use this on and off. So it must reflect the same in the LED, but it is not. Then we have to check the serial monitor first, what it is showing there, whether it has received on and off. Let us check. Yeah, it is received. So there might be circuit issue. So let's check it out. Now again we try. Yeah, so the connection was loose this moment. You can check it out. The simple subscribe is there. So we have subscribed to this lamp event. So this control signal is sent from this IO AdaFruit to our NodeMCU. So the same we can see in the serial monitor. So this is the subscribe example. I hope you got it.